Right. 8.3, injective, surjective, bijective. This is what we need to know. Now, this is your input, this is your output. We can see that this is our codomain and this is our range and this is our codomain. Yeah, you can get confused with those every so often. It's explained on a page, just right back at the start. Page 232. So this is our range. This is the measure from the top to the bottom of the outputs, and our codomain is here. Now, how are we going to do this? This is what you'll probably need to note down. Now, we're either going to be given this in this form or this form. Yeah. So, or the only other thing is you must say f of x equals to x squared. You can map that out to be like this. Straight off, I'm looking at this. Injective, is there one input for every output? Yeah, perfect. Surjective, the difference is I've got one input, one output. But, hold on, I got two inputs, give me the same output. So that'd be like minus 1 on 1 and x squared. So they both give us 1, they both go into that. Okay? Is the range and the codomain the same? No? Okay, if it's no is the answer, it cannot be surjective. If yes, it can be surjective. Now, injective, you can have the range and the codomain the same. Test number 3 for this. If I go to any point and draw a line across, will it hit any other point? If it hits another point, it can't be injective. If it only hits one point, it can be injective. Now, this one here, this goes across, hits 2 points. That can be surjective. Surjective has to hit at least 1 point. Okay? So if we're going to go down here, cubic, that can be surjective but can't be injective. Now, if I give you the following, I know this can get confusing. Bijective. Bijective is the combo of the two. So the codomain and the range are going to be the same, and it's mapping 1 onto 1. Example of that is x squared, but x is an element of n. So the range is 0 to infinity, the codomain is 0 to infinity, great, 1 maps onto 1. Yeah, draw a line across at any stage. Perfect. Let's look at examples and then you can go back and go over this yourselves. So get onto the correct page. First one, I'm going to explain. I'm going to move the camera to give myself a bit more room here. Okay, very first one. That one. Codomain and domain and range are not the same, so it cannot be surjective. It doesn't map 1 onto 1. Both of these go onto input, go to the same output, so it can't be injective. Is it a function? Yes, because 1 goes to 1 the whole time. Okay? This one, 1 goes to 1, codomain and the range are the exact same. Yeah. So, 1 goes to 1. Perfect. That is injective and surjective, making it bijective. Terrific. Next. Straight away, just look at this and it says, why is it not bijective? Codomain and range aren't the same. Yeah. Is it a function 1 goes to 1? Yes. 1 input goes to 1 output. Does it go to... Is it injective? Injective, well, 2 go to the same one, so it's not injective. Is it surjective, codomain and range aren't the same? No. So therefore, it can't be bijective. Question 3. 1 to 1. Perfect. That is surjective because it's 1 to 1. Or, yeah, for every input there's an output. But they can also have 1 input, 2 inputs can go to 1 output. The codomain and the domain are the same, so that's surjective. This one here is injective. 1 input to 1 unique output. and the codomain and the domain are the same, so it rules out surjective and bijective. 1-to-1, that is injective. Okay? While also being surjective, making it bijective. It's surjective because the codomain and the range are the same. 4, that is surjective because two inputs go to the same output. Yeah, codomain and the range are the same. Why is it not bijective? Because two inputs go to one output, making it impossible to be injective. So bijective needs both conditions. Right, this one. State whether each of the following relations is, well, this is 2 is to 3, 3 is to 4, 5 to 4, 4 is to 6. Okay, as you can see here straight away, is this injective? No, because you've got the same outcome. Think of it, the y-axis, line across, that would potentially be surjective. Only problem here, is it a function? For every input there's an output. It's not like it goes 2, 3, 4. Yeah? And that does that. So this one, saying, is this injective? No. Is this injective? Yes. For every input there's a different output. Yeah, that's all you've got to look at. Right. This one. Explain why this is both injective and bijective. Okay? Straight away. What would your range in codomain be? Minus infinity to infinity, because a line goes there, making it surjective. This goes across, it hits at least 1 point, done. This hits 1 point, yes. Every input has one output, yes. Therefore, it's both injective and surjective, making it bijective. This isn't really a case of where you're going to go and do questions. This is a case when you're just going to look at all these questions and you're going to go, without writing them down, look at it and then try to get it out, if that makes sense. So like I was there going, trying to explain it to myself and then doing that. So I'm not actually expecting that you put in anything for the homework. I'm expecting that you put in the 40 minutes and try to realise what works. So if I can explain this one, is that explain what a graph on the right does not represent a function. Okay? So, if you think about it, what represents a function? Every input has to have an output. Yeah? Every input. But you can't have two inputs, or you can't have two outputs, or one output that gives you... So one output here is 1. If you draw a line down, and it gives you the same input. Not a function. Sideways crap, not a function. Okay? So, that's not a function. I don't really need to go through this again. This one here, line across, straight away, ruling, line across, ruling out that it's injective. Is it going to be and bijective as well? Is it surjective? Yes. Every input has a unique output. Perfect. Yeah, codomain and range are going to be saying it goes from minus infinity to infinity. Great. Happy days. Right, 40 minutes tonight. Go through that. That kind of wrecks your head, but you'll get it. You will get it, trust me. Any questions, just ask.